I'd like to now give you an example of an organic reaction, specifically esterification. If this is going to have a direct relationship to something we're going to do in a little bit. Alright, so what we're looking at here is a reaction between a carboxylic acid and an alcohol. And what happens is they join together to form an ester with the release of water. The H plus here is a catalyst. So the pattern for this reaction is that the O from the alcohol joins on to the C double bond O from the carboxylic acid, and we lose the OH of the carboxylic acid and the H of the alcohol, and those become water. So let's look at an example of that. And here we have it. So what I would recommend you do is set this up so you've got the carboxylic acid and then you've got the alcohol, and put the alcohol above it or below it, whatever looks nicest to you. Whatever will allow you to get this into position for the best joining. And what's going to happen is that the O from the alcohol will join to the C double bond O from the carboxylic acid, and then we lose the H of the alcohol, the OH of the carboxylic acid, and that'll give us the water. So our final product is going to look like this. Now, of course, there's many different ways this can be drawn. And still have it correct. Let me show you one other thing you could do here. And that's the same thing. So it doesn't have to be drawn exactly as I've got it here. You can draw it in any way as long as everything's connected where it's supposed to be connected. Alright, so that's the esterification reaction, how we join. I also want to point out that the order here is immaterial. We can have the carboxylic acid first or the alcohol first. It isn't going to matter. It's still going to get the same product in the end. Alright, so let me delete this down here. Alright, let's take a look at the next reaction. And this is the hydrolysis of an ester. So what we're doing is we're using H plus and water to break the ester back into a carboxylic acid and an alcohol. Now the pattern for that one is we break the C double bond O and the O bond. That was the original bond we formed, if you remember. That one breaks, and then we push an OH onto the C double bond O and an H onto the oxygen. That will allow us to get our carboxylic acid and water products. Alright, so let's take a look at an example of that. So here we go. Now I've used H3O plus here. That's equivalent to H2O and H plus. Alright, so the NO2 and everything else here just pretty much stays the same. And what we're going to be looking at, I will redraw this and then show you the pattern. We're going to break that bond there, and the water is going to join on to the places we said it would. So the O from the alcohol portion will take the H, and the C double bond O from the carboxylic acid portion will take the OH. So C double bond O takes the OH, the O takes the H, and we end up getting our products, and our products look like this. So So I just draw this exactly as it's drawn here. The details of what these are doesn't really matter. It's all that matters is what's going on with the functional group here. So we'll get that plus this one here. And that's it.